Right, on to multiple bonds. So before we talked about how when we drew the Lewis dot structures and then started looking at the orbital diagram that happens, it can get complicated, but we're kind of visualizing mixing the quantum chapter with the Lewis dot structure. And so the initial bonds we form are all sigma bonds. And when we start looking at more complicated things, then we get where we have pi bonds. So we don't use all the p orbitals, and the left behind p orbital are used to form these pi bonds, the second double bond in this structure. So sp3 is easy, a steric number 4, so you just count up. But then everybody wants to just which label all of them as sp3, and it is the most common. But when we start to have multiple bonds, then the key thing is that second bond is left over from a pure p orbital, and so that means that we don't mix it. Or you can just see this carbon has three things around it: one, two, and three. These count the same. And so three things, we need three orbitals, we need one s and two p. All right, the leftover p, then if we do accounting, we can associate with the second one. So we have three sigma bonds and one pi bond. And so you're given simple compounds like this in this website. And first, you have to kind of flip it and just know it's the carbon-carbon connectivity and the hydrogens go around. So the kind of structural relationship. And hopefully from the other chapters, then you can picture like this, the hybridization, the bond angle, VSEPR, stuff like that. And so at the end of the day, though, you just need to translate this into the Lewis dot structure and then see how many sigma bonds, the initial connectivity, and how many pi bonds. If we look at something like this, then you start to see a simple picture like this, and maybe you can get the answer again with VSEPR. And now from Lewis structure, I would do the initial connectivities with the red, and then pairing up that last unpaired electron then tells is the pi bond. So we have one, two, three things around this carbon, and then a double bond there. So if those are simple hydrocarbons, and then you can just swap out the halogens and you get the exact same thing. So we can start to see the same motif in a wide range of structures. And so that's really the kind of goal is, can you start to see that? All right, so in the website, I give you the simple formulas, and you have to draw a Lewis structure and then count it. On the exam, then you may be given a structure and you just have to count it. I just didn't incorporate pictures into the website. And so again, these are some simple ones, and then just simple counting how many sigma and how many pi bonds.